Right, so in this video, I'm going to be solving and verifying equations where distributive property is involved. Now, the last video I did involved modeling. Now, I don't want to draw anything out in this one, so I'm going to be using the distributive property, and I'm actually going to show you two different ways. I don't care which way you want to use. I do want you to make sure you understand how the distributive property works, so it's good to practice that. But if you find the second way of solving this easier, by all means, you are allowed to do that. So this one says 2 times, and then in brackets, I have x plus 3 is equal to negative 6. So the first thing I'm going to do, I'm going to get rid of those brackets. And here's how I get rid of those brackets. I'm going to take that 2 that's in front, and I'm going to distribute it into the brackets. So that means I'm going to multiply everything inside the brackets by what's out front. So 2 times x gives us 2x, and then I'm going to take that 2 and also multiply it by the positive 3. Positive 2 times positive 3 is positive 6, so I'm going to put that positive in between the x and the 6. And I put that positive in between because the 2x and the 6 are separate terms. If you think about the diagrams I did in the last video, the x's are represented by those green rectangles, and the ones were represented by, in this case, they're positive, so those red squares. They're different types of shapes. They are different things. So we keep them separated by either a plus or a minus sign. And you can see once I've done the distributive property, really this is just solving a two-step equation. And you've been doing this for a couple of weeks now. So I'm going to subtract 6 on both sides. I'm removing the constant on both sides. That cancels out my 6's. And now I'm left with 2x is equal to negative 6. Subtract 6 more or take away 6 more gives me negative 12. And now my opposite is to divide both sides by 2. And that gives me that x must equal negative 6. Okay? Now I've said x should be negative 6. And I'm going to go back and I'm going to verify, which means double checking that I have the right answer. So remember, I go back to what my original equation was. My original equation had negative 6 on the right-hand side of the equals sign. The left-hand side of the equals sign, before I did distributive property, had 2 times x plus 3. So I have said that x shouldn't be x. It should in fact be negative 6. So I'm going to try putting negative 6 back into my equation and see if it works. Now, looking at this, it's 2 times, and in brackets we have negative 6 plus 3. Because of order of operations, because of bed mass, I must do what's in the brackets first. So I'm going to do that operation inside the brackets first. Negative 6 plus 3 gives me negative 3. Now I still have the brackets there, but there's nothing going on because I just turned it into a single answer. And so now this statement says 2 times negative 3. Well, positive times negative is negative. 2 times 3 is 6. So we get negative 6 on both the left side and the right-hand side of the equation. So we have the correct answer. Okay, let's do another. This one, 4 times, and then in brackets, I've got x minus 2 is equal to negative 20. So I'm going to show you the other way you can solve this one. All right. Now, I think I've said to you once before that when we're solving equations, it's kind of like working backwards through our order of operations. So if you were pretending to be standing where x is, if you were in x's position, the first thing that would happen is we would take away 2 from you, and then we would multiply you by 4. If I was going to undo that, I would actually have to go backwards through my order of operations. Since I'm going to work backwards through my order of operations, I get into the brackets last. So when I've been doing my solving equations, I've been getting rid of any adding or subtracting first, and then getting rid of any multiplying or dividing second. I'm going backwards through my order of operations. Well, that would mean I would get rid of adding, subtracting first, I would get rid of multiplying, dividing second, and I would actually get rid of the brackets last. So what I'm going to do instead, I'm going to start by dividing both sides by 4. Now, it's important to hear what I said. I'm dividing both sides by 4. So everything is being divided by 4. And you'll talk more about this in grade 9. But if I divide what's in brackets there by 4, I really am doing distributive property there too, aren't I? So if you think about it, I would multiply the 4 by the x, but then I would take x and divide it by this 4, because both things are being distributed in. And then I would take that 4 and I'd multiply by the negative 2, and then I would take that answer and divide it by the 4 that's in the bottom. And so really, because I'm dividing both sides by that 4, it undoes the multiplying by 4 that goes into the brackets. So I can get rid of that first. All right, really what's happening is I'm kind of just canceling out those 4's so that I don't have to do any distributive property. And now I have this. I've got x minus 2 is equal to, on the other side, negative 20 divided by 4 gives me negative 5. And then my opposite of x minus 2 is equal to negative 5, I'm going to add 2 on both sides. And that leaves me now with x is equal to negative 3. So we kind of save a step when we do it like this. We don't really need to do the distributive property. I don't need to multiply that value in if I simply divide both sides by that value in front of the brackets. So again, it's your choice as to which one you like. I do need you to understand how to use the distributive property, so I'm going to continue to show that. But this would be just as valid and correct if you were to do it this way, and I would certainly not mark you wrong. So I have made a statement saying that x should be negative 3. So I'm going to put that back in, because I'm pretty sure x should be negative 3. Now again, on the left-hand side, I have to figure out what's in this set of brackets. First, negative 3, subtract 2 more, gives me negative 5. I still have that 4, that's in front, and 4 times negative 5 is negative 20. So we get the same thing on the left-hand side as we do on the right-hand side. Okay? All right, really fast now, less explanation. So multiplying into the brackets using distributive property, that one gives me negative 7 times x. Well, that's just negative 7x. Then I'm going to multiply, again, that negative 7 by the positive 4. That gives me negative 28. And yes, I'm going to write down the negative in between because I need to keep my x separate from that second term. On the right-hand side, I still just have that 49. That negative 7 that I'm multiplying by only happens to the brackets, not something that I'm doing to both sides. Doing my opposites, I'm going to add 28 on both sides of the equal sign. I'm going to treat both sides equally. And now I'm left with negative 7x is equal to negative 49 plus 28. There's a difference of negative 21, more negatives than positives. Okay, so we have negatives left over. And then I'm going to divide both sides by negative 7. When I divide both sides by negative 7, I'm left with x is equal to 3. So again, I'm going to check to make sure that I actually have the right answer here. Okay, so I started with negative 7 times x plus 4, that was in brackets, and on the right hand side I had negative 49. Now I said x should be 3, so I'm going to try putting that 3 back in instead of writing x. I got to do the brackets first. 3 plus 4 is 7. And then I have negative 7 times 7. And negative times positive is negative. And 7 times 7, that gives me 49. We have the same thing on both sides. Now again, a question that is kind of beyond the scope of grade 8, but I think totally solvable for you guys. Or sorry, this one's not beyond the scope of grade 8. My apologies. I just wanted to do one where I messed with you and threw it on the other side. Oh no, x is on the right. Whatever shall we do? Oh no, we're so used to x being on the left. How could we ever possibly solve it because it looks different and scary? Well, I'm going to use the same properties. Distributive property, multiply that 5 into the brackets. 5 times x is 5x. 5 times negative 6 is negative 30. I got to get rid of that constant. I got to get rid of that 30, that negative 30, so I add 30 onto both sides. Now I've got negative 10 is equal to 5x. And then I got to divide both sides by 5. And there we go. I got negative 2 is equal to x. It doesn't matter what side x starts on. I'm still following the same process to get x by itself, where we say isolate the variable. I want to get the letter all by itself, and it doesn't matter what side it's on, I can still do opposite operations on both sides. Okay, so now I'm going to put in that value of -2 for x, and this time it goes on the right hand side, so it looks different, but really I'm doing the same things. I'm going to multiply, or do what's in the brackets first before I multiply. -2, take away 6 more gives me -8. I still have that I still have that 5 in front. +5 times -8, -40, and look at that. We get the same thing on both sides. Just happened that my x, my variable, was sitting on the right hand side instead. There is solving using distributive property. So again, I don't mind if you want to use the arrows and distribute in. I do need you to understand how to do that for grade 8. But if you'd like, for solving, if you find it easier, you can divide both sides by that number that's in front first. That is a valid way of solving it.